Hi, and welcome to my second vlog in which I'll be looking into capacity and skill issues in both a speed and an agility drill. As for the speed drill, I asked two athletes to perform a stance sprint start to initial acceleration. As for the agility, two other athletes performed 90-degree lateral shuffle cutting drill. The athlete, who was a professional goalkeeper with a previous history of an ACL injury approximately 5 years ago, has a lack of capacity during the speed drill. We start by looking at the athlete's sprint and how he performs the task. One could clearly note that the start position within this athlete is a closed and compact one with the back leg planted onto the ground. Ideally, the rear foot is placed in a slight ankle plantar flexion to mimic the block starting position. In conjunction to this, the athlete has a quite high center of mass. Scott and colleagues in 2013 analyzed 12 sprinters during both the block start and stance start, which concluded that lowering the center of mass before takeoff led to larger propelling impulses and greater horizontal velocities at takeoff. During the first steps of the run, the athlete lacks full extension from the trunk down to the ankle. One could also note a low knee drive with a low degree angle in the hip trunk complex. According to Higashira et al. In 2014, a forward trunk lean resulted in risk of hamstring injuries due to elongation load. Such changes in kinematics could possibly be indicative of having decreased mobility at both the hip and thoracic areas. To assess the capacity issue, I started with comparing the athlete's active hamstring movement to assess the hamstring's flexibility. In 2015, Williams et al. Found that hamstring flexibility is significantly correlated to biomechanical changes in sprinting, which in turn increase risk of further hamstring strains. Going on to overhead squat, the athlete shows an excessive forward lean and arches the lower back, which could possibly be due to overactive hip flexor complex as compared with the technical model by Bishop et al. In 2016. Whilst assessing active hip flexion and standing, a noticeable trunk forward lean was present, which is indicative of hip flexor complex tightness. Other measures taken to assess when muscle imbalances present within the hip and knee joints were isometric testing looking at max force and asymmetry. It was clearly evident that no significant differences were seen when comparing left to right. Therefore, I discussed with the athlete to start performing static and dynamic stretches as part of the warm-up and the graded eccentric strengthening as accessory exercises throughout the week. Samson and colleagues in 2012 looked into participants performing competitive sports and found that both static and dynamic stretching within an activity-specific warm-up ensured maximal range of motion and enhancement in sprint performance. Seen in the systemic review of Bawista in 2021, the use of neuromuscular loading by eccentric work for both hamstring and quadriceps induced a positive amount of strength maintained sprinting performance whilst reducing hamstring strains. Also included B drills to improve coordination, actively work on hamstring flexibility, and widens the range of the hip whilst maintaining an upright position. After some cueing and showing the athlete's faults, he was able to perform the B skips in a better form. As part of the coaching, I also added step-up jumps and wall drills to work on explosiveness of the movement as needed during the sprint acceleration phase. Et al. 2021 clearly explains the need of sprint-specific drills as to be able to produce higher forces during the movement itself. This overview shows that decreased joint flexibility could alter the kinematics, which leads to the ability to produce such high forces with minimal energy expenditure. With coaching cues, drills, and athletes' understanding of what is needed, he was able to improve his sprint kinematics within a short time frame. The following athlete is a national netball player who clearly shows altered kinematics due to lack of skill. Such movements and skills are required through practice until it's executed automatically. It's of utmost importance that such athlete improves her technique patterning of muscles during a sprint as to decrease energy consumption to travel short distances during the sport and to utilize more energy during critical movements such as change of directions and jumps. Orendorf et al. In 2018 found that altered kinematics and kinetics led to changes in peak power generation and more energy cost. Seen initially during the stance position, the athlete places both the right foot and arm forward. During the first step forward, there is lack of full extension with a high forward head tilt, low knee drive, and low ground clearance. This is constantly seen throughout the run. Looking closely, the athlete produces an excessive arm swing which skips the midline leading to trunk rotation. Limited research is present on the effects of arm swing during the sprint. However, arm-leg synchronization is vital during block start sprinting as found in McAdam et al. 2018. On assessing, no limitations were noted during the active hamstring movement. Interesting to note, however, is the overhead squat assessment. As the previous athlete, this athlete showed a limited depth with the trunk leaning forward and an over-arched lumbar spine, possibly due to hip and thoracic mobility. When assessing hip flexion in standing position, the athlete shows adequate and similar ranges on both. Dynamometry isometric strength testing showed no significant differences between both lower limbs. I started by breaking down the sprint technical model, asking the athlete to perform the simplest form of A drills, that is A marching, as to introduce the knee drive and ankle dorsiflexion. This was followed by adding plantar flexion to help the athlete familiarize its triple extension movement. Ultimately, as seen in the study of Wellen et al. 2016, A skips were performed as to develop coordination and optimal movement required during the sprint. I also introduced the athlete to wall drives. The athlete is purposefully looking downward as to have visual feedback and better understanding of the movement required. Initially, focusing on the hip and knee movement, which was followed by ankle plantar flexion of the fixed leg. This allowed glutes, hamstring, and gastrocs to work into extension, which is a replication during the sprint. As found by Dean et al. In 2005, an improvement in sprint performance with performing wall drills was seen in college volunteers who were not sprinters. The use of lean fall to sprint drill was used so that the athlete goes onto tiptoes. The use of lean fall to sprint drill was used so that the athlete goes on tiptoes, leading to the first drive motion with the opposite elbow up with good placement of arms and legs. A near to full triple extension pattern is seen through the rear leg with a stronger knee drive. Even though the athlete might have capacity limitations, I'd rather focus on coaching the athlete to improve the sprint ideology first, followed by improving the athlete's capacities. Schmitz et al. In 2014 concluded that lack of technique in sprinting can lead to increased energy expenditure and increased risk of injuries. The following athlete is a casual football player who is limited by capacity whilst performing a 90-degree lateral shuffle agility drill. The limited capacity is clearly shown with a lack of triple extension through the rear leg and a decreased knee drive in the leading leg. On arrival to initiate lateral shuffle, pushing through the right leg, a noticeable knee valgus ground contact push with a high and left-sided center of mass is present. Also, trunk is kept in extension, lacking the ability to remain in stance position, which could possibly lead to more force output to counteract gravitational forces. This is backed up with the study from Luciano et al. 2022, concluding that higher center of mass, especially at higher speeds, leads to more energy expenditure and possibly altered mechanics. When lateral shuffling to the right side, once again, knee valgus is evident in both legs. However, the right leg has a higher degree of dynamic knee valgus. The moments present within the knee valgus position lead to an increased risk of ACL and patellar femoral joint injuries. During a literature review, Wyszynski et al. In 2020 shows that this knee valgus was mainly due to gluteal maximus and TFL weakness. Extensive evidence has shown that increasing muscle strength and stability around the hip and improving ankle active range of motion alters knee kinematics during change of direction and agility movements. Firstly, dynamometry testing showed a discrepancy in maximal force output when testing gluteal maximum strength. Favorable measures to the left limb was noted in both long lever and short lever testing as suggested by Aramek et al. In 2016. I further assessed the athlete's dynamic movements by assessing single leg drop jump. Once again, a noticeable deficit onto the right lower limb in comparison to the left was seen. Such measures were height, peak drive of force, and peak power. On performing the counter-movement jump, a higher percentage of concentric and eccentric forces towards the left side was noted. This implies that the athlete is mainly left leg dominant when arriving to deceleration and pushing off to a lateral shuffle. I also assessed lateral hops from a fixed point, which also showed an approximately 20 cm difference, confirming the left leg dominance in such athlete. I decided to start the athlete off with air squats, focusing on pushing the knee outwards and penguin walks against resistance band. Foley et al. In 2017 through AMG readings show how the band works as a proprioceptive aid, while including activation of the agonist muscle. Also, these two exercises specifically increases knee stability through activation of stabilizing muscles around the hip and the knee joints. Specifically, the penguin walks provide a constant isometric resistance during squat locomotion with a focused low center of mass. Also, reactive single leg drills were added to the routine as to work on single limb power and stability. Initial sprint movements have been seen with a much more favorable angle of the hip, knee and ankle complex and also an improved knee drive. Also, knee valgus on pushing off into lateral shuffle improved with slightly lower center of mass for both the left and right side pushing. Further coaching, strengthening and cueing is needed to enhance such movements. Next athlete is an amateur netball player presented with an agility skill issue. Going onto the lateral shuffle, the athlete is looking towards the ground. A carioca foot pattern is seen rather than a lateral shuffle movement with a high center of mass present. The lateral view shows how the athlete took a rotatory pattern rather than a straight line shuffle. This clearly shows that the athlete is lacking both the skill and understanding of the movement. As to eliminate any capacity issues, firstly I went through assessing range of motion for both the hip and ankle to rule out any mobility issues in which no visible limitations were present. Assessing dynamically, I opted for the single leg horizontal jump and compared the distance between the left and the right limb. Measures for such hops were 1.11 meters for the left and 1.13 meters for the right, meaning no significant difference were noted. Similarly, lateral hops measures were taken, resulting in a 72 cm to the left side and a 74 cm to the right side, concluding no specific capacity limitations present. As seen in the study of Lombardi in 2018, multiple acceleration-deceleration movements are present during a netball match, with athletes risking further injuries due to altered biomechanics. Therefore, I started off coaching the acceleration-deceleration phase of a run, focusing on the deceleration stance position. With the help of cueing and the athlete's understanding of movement, we were able to achieve a better stop position with a low center of mass, head facing forward and feet aligned but wide apart. This was followed by breaking down the lateral shuffle, starting with lateral walking along 2 points of reference, moving to banded lateral walks, and ultimately lateral shuffles. As stated by Silveria in 2021, this type of coaching helps the athlete improve their neuromuscular adaptations and movements through muscle memory, leading to a force of habit. Reviewing the movement, the athlete was now able to perform such agility drill in a more professional way with minimal cues and teaching. As to summarize this overview, Athlete 1 presented with a limited capacity during a sprint, mainly due to the lack of mobility around the hip complex. The inclusion of stretches, eccentric work, and specific activity exercises led to improvement in the movement kilogram. Athlete 2 lacked knowledge of the sprint kinematics. It is vital to work on cueing and movement breakdown, since with the coaching tips given in a short period, Athlete was able to improve such movement. The third athlete showed a capacity issue during the agility drill due to the differences in the strength measures, leading to increased risk of injury. Further strength training and single leg work is required to further improve such limitations. Finally, athlete 4 displays a skill issue whilst performing the agility drill, lack of knowledge on lateral shuffle and during the acceleration-deceleration phase. Coaching emphasizing on corrective cues and movement breakdown is crucial.